right, we're going to look at using appropriate statistics to compare data sets. We have two types of distributions. Well, we have distributions of data that we need to talk about. We have skewed distribution. This is when the distribution of data has a shape that is stretched out in either the positive or the negative direction. So we're going to talk about these in more detail, but this is a skewed left. You can see it looks stretched out in the negative direction. Skewed right is stretched out in the positive direction. So that's what a skewed distribution looks like. Versus the other type is a symmetrical distribution. The distribution of the data has a shape that is symmetrical. So you can see kind of that in the middle here, left side is mirroring the right side. That's a symmetrical distribution. So how can we describe the different types of distributions? So let's start by talking about when your distributions are skewed left. The shape of the data is stretched in the negative direction. Also, oh, I don't have a lot of space. Let's see. The mean will be less than the median and mode. And if we just take a look at a skewed left distribution right here, you can see the median and the mode are here and the mean is to the left of that. When your data is stretched to the left, that's going to pull the mean toward the left. So it's going to make the mean less than your median and mode. Your mean, so the mean is more affected by the data. So if the data is skewed left, that's going to have a bigger impact on the mean than it does on the median and mode. All right, let's talk about our symmetric distribution. So in a symmetric distribution, the shape of the data is symmetrical. And the mean, median, and mode are about the same. Okay, now let's talk about if your data distribution is skewed right. So the shape of the data is stretched in the positive direction. So if we take a look at a picture of that, if you're skewed right, you can see it's stretched to the right in the direction, or in the positive direction is how they phrase that. Also, the mean will be greater than the median and mode. And if we look at our picture, we can see that. Here's your mode and your median. By the way, mode, if we haven't used that word yet in this unit, that's the data value that occurs most often. So you can see if your data is skewed right, if the distribution is skewed right, your mean is going to be greater than. It's going to get pulled toward those higher numbers. So your mean will be greater than the median in mode. And then let's just add on to here, we said it on the other one, but the mean is more affected by the data. Okay, so part B, what measures of center and spread would you use for the following data set? So here's our data set right here. And then using a histogram is a really nice way to see the shape of your graph, or sorry, the shape of your data distribution. So what we notice in looking at the shape is it is skewed to the left. It looks like it's pulled to the left in the negative direction. So our data distribution is skewed left, or the data set is skewed left, which indicates that the mean is more affected by a data distribution than the median. So the reason why we talk about that, they're saying what measures of center and spread would we use to help describe this data set? We would not use the mean in a data set that is skewed left because the mean is more affected by the data than the median. So a median would be a better measure of center than the mean would. So I thought I was recording as I wrote that out, but let's make sure we add this in. Therefore, it is better to use the median and the interquartile range as the measures of center and spread. So the median is a measure of the center of your data, and the interquartile range is a measure of the spread. Let's just also note that the quartiles show how data are distributed on either side of the center of the mean. All right, so let's find the median, range, and interquartile range. So we could type these numbers into our graphing calculator and do the one variable stats like we saw. We also could notice that these numbers are already ordered least to greatest. So we could just quickly count out the median and our interquartile range. So if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers in our data set. It's an odd number, so there will be a number right in the center of this. 1, 2, 3, 4, 5, 6, 7. It's going to be the 8th number because there are 7 numbers on either side of this. So this is our median. The lower half of our data is where we'll find quartile 1. So let's count 1, 2, 3, 4, 5, 6, 7. So there are 7 numbers, 1, 2, 3. The fourth number will be quartile 1. So Q1 is 21. And then the upper half of our data, let's count that. We have 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, the fourth one, this 33 is our Q3. So we can quickly find that the median, is 29. The range of the whole data set is, let's take the maximum value 37 minus the minimum value of 10, and so we have a range of 27. And then the inner quartile range is Q3, 33, minus Q1, 21. The inner quartile range is 12. So those measures of center and spread, the median, the range, and the IQR, are a better representation of the data set than the mean would have been.